Welcome. My name's Todd Sigler. I'm the Vice President of Product Assurance at Cirrus Design. We're going to take you on a behind-the-scenes tour of the Cirrus Design Duluth factory. Unfortunately, today we don't have time to go to our North Dakota facility where all of our composite laminates are laid up and constructed. But we're going to get you behind the scenes here in Duluth, get you everything from where the parts enter the factory to where the airplane rolls out ready to be delivered to the customer. So I hope you enjoy this time. We're standing out right now on the receiving and shipping docks. This area, as you can tell, is the location where all of our parts and materials come in from our vendors. It's a pretty highly active area, as we do have quite a long list of suppliers that we have a good partnership with and have a good relationship with in terms of delivery and performance. One of the things we try to highly promote is returnable dunnage. That is containers that the supplier can send us parts in that we can then turn around and send back to them. Obviously, it's kind of a green aspect on the environment, but it's also better for the supplier too, so they don't have to continue putting cost into just boxes and crates going back and forth. This area is where we start to collect the inventory for our composite parts that come in from Grand Forks. Our Grand Forks facility makes nearly all of the composite parts for the airplane, and they come here first, and we have a FIFO order, a first in, first out, in which we keep track of our inventory. So the parts will come in here first, get put into stock, and then as needed, we'll pull them into the abrasive booth to prep it for bonding. This is one of two areas in which we start to prepare the composite laminates for construction and assembly in the Duluth plant. All of the composite parts that we receive from our Grand Forks facility make their way through one of these booths prior to being assembled. We have an abrasive material that we use with an air gun and spray the areas that are going to be bonded. That way it helps take away the sheen and prepares the surface with the right texture for adhesive bonding down the road further in the assembly process. As we do that, we'll break the parts down into a kit format for their better and more efficient utilization on the floor. The carts next to me are broken down in that manner, in which the way in which they're going to be consumed on the floor, they group them together so that makes it easier and more efficient as we process it through the abrasive booth and get it to the technicians on the floor, so they have everything that they need part-wise for that part of the operation.
Sunny or cloudy, rainy or bright, day or night. The future of flying is now clearly in sight. Garmin SVT, synthetic vision technology.
The area behind me is where the airplane really starts to take shape. The two fuselage halves that you see to my right are being prepped for beginning assembly of the fuselage bond process. Further behind me, the floor begins to take shape, and finally at the end, the two fuselage halves are wrapped around the floor structure and some structure in the tail. We try to maximize our ergonomic benefits by putting tooling at the worker level. We try to we rotate pieces right side up, upside down, whatever it takes to make sure the employees aren't spending a lot of time bent over on their backs or straining to complete their task. The machine we have in front of us now is what is used to do the final assembly of the fuselage structure. We use heat-in-place technology with hot air and with electrical heat tapes for the curing process. That's one of the reasons you see the plastic drape, if you will, around the machine, is that so we can best control the temperature ramp, maintain the temperature, and then when we are towards the end of the curing process, ramp the temperature back down. As you can see, the technicians right now going in and ensuring that we have adequate adhesive in the joints, and then when they're done, they'll close the thing up and it will cook the adhesive, if you will, for a predetermined amount of time. And once that's done, except for some trimming operations, basically the fuselage structure is complete. And as we saw earlier, there's a significant amount of the internal hardware installation that's already been done as well.
Cirrus Design's Vision SJ50 single-engine personal jet offers exceptional fuel efficiency, flexible seating for up to 7, advanced avionics, and all the Cirrus safety features you expect, including the Cirrus airframe parachute system. With its detailed design, the Cirrus Vision is technologically advanced, yet engineered to be simple to fly, to allow owner pilots more lifestyle pursuits than any other personal aircraft. Learn more about the Vision SJ50 at cirrusdesign.com.
We've now come into the wing bonding area, and much like the fuselage shop, we have a very organized and efficient approach to putting the wing together. Some of the tooling you'll see in this area is similar to the fuselage tooling in that we take smaller sub-assemblies and then bring them together at one point in a culmination of finished bonding to create very large assemblies of the wing. One of the advantages, again, when we went to the G3 revolution on the Cirrus product line was combining a lot of individual operations into one larger operation. So we were able to take 6 or 7 different individual bonding steps and combine them into one. Obviously that increased our efficiency tremendously, being able to put more product through with the same amount of resources. Again, behind me you'll see some of the technicians working on half of a wing. Again, very mindful of the order in which we put the airplane together to give us the right amount of access to what would otherwise be close quarters after the wing's finally assembled, to do some installation of hardware and wiring and fuel and plumbing and such. We try to do as much of that as we can while part of the wing is open. The G3 and like all of the other Cirrus predecessors are of a wet wing construction, i.e. the structure of the wing itself makes up the fuel bays. Inside of the wing we also obviously have an amount of wiring and plumbing and hardware that has to be installed. Obviously when our technicians are complete, we have a multi-stage process by which we ensure the job was done accurately and completely. The technicians not only sign off on their work, they also have an area lead that will first sign off on the work that they have completed, and then finally somebody from our quality organization and an actual manufacturing inspector will come and review the work as well. Here you see one of our inspectors looking at the bond lines. Not only is he looking at the thickness of the bond line, but he's looking to ensure that it doesn't have any voids or air bubbles trapped in between. And again, by using a strong flashlight, you can actually kind of use a backlighting approach to make sure that you don't have any defects in the bond itself. Obviously, the carbon spar is different in that respect. It doesn't have a translucent characteristic, and we have to use ultrasonic technology to actually beam sound waves through the laminate and into the bond to inspect for bond line completeness and quality.